So as we have seen, we are facing an issue with the safeguards that are addressing the level increase in the vessel due to high flow. Now, to get to the point more in depth, we need to analyze the causes in more detail. We have talked that the cause may be related to the whole plant, such as power failure, instrument air failure, or general failure in the control system. In these types of failures, the whole plant should be stopped. So in this case, we are already considering shutting down SDV1 and SDV02 in case of any scenario related to a common cause as shown in the cause and effect matrix. There shall be no more recommendations. But what about the local failure? Let's see. The other type of cause is related to the local control loop itself. In this case, we can consider the level control loops on the waterline as a safeguard since they are independent control loops. So, as the level rises in the vessel, the level controller LIC01 shall send a signal to LV01 to drain water. However, this is not the case with the oil line. If you recall in the PFD, there is just a flow controller on the oil pump discharge. In addition, the time for the operator to respond will be less than 1 minute in case of excessive flow. So here, there should be enough room for the operator to respond. The level controller on the water line is supposed to give some time for the level to rise, in addition to the time that is given to the operator in case of high level alarm. But still, this may not be enough. We should seek other solutions to give enough time for the operator to respond. This can be done by several solutions, such as increasing the size of the vessel. However, this may cause a huge cost impact, especially if we are in a late stage of the project and the HAZOP is commonly carried out after the design issue, as we have shown previously. So this is considered a relatively late stage in the project. It can also be through adding a mechanical stop to FV01. This shall be through studying the maximum flow rate that the control valve FV01 can pass when it is fully open. This can be known by knowing the valve's rated CV, which is the CV of the control valve when it is open at 100%. If you like, I have made a course talking about the control valve and I have talked about valve CV in detail, so you can check it out if you like. If we knew the maximum flow and we already know the vessel size, we could know the expected timing at this flow. A mechanical stop shall limit the valve from getting fully open and let its maximum opening be at a less opening. For example, we can let its maximum opening at an opening of 80%, not at 100%, and this can limit the maximum valve flow rate and hence increase the time for the operator to respond. However, we should take this solution with much care, as it may cause issues during normal operation that may lead to limiting the flow. Maybe the valve is already working at more than 80% opening if we added a mechanical stop at 80%, and this shall limit the flow during the normal operation. Another solution can be to ensure that the oil flow to the desalter is linked to the level in the vessel. This can be made using a cascade signal that shall adjust the set point of the flow at the pump discharge. This shall mean that the set point flow of oil shall increase in case of high oil level in the vessel, which shall mean that the level rate of accumulation in the vessel shall decrease. This shall give more time for the operator to respond and may even prevent the vessel from overflowing. As the HAZOP shouldn't be challenging the design and it shouldn't give recommendations related to changing the design, the recommendation here would be a general recommendation, which is that the engineering team should check a solution to give more room for the operator to respond. In addition, another recommendation shall be that the operating manual should clearly consider the exact procedure that should be strictly followed in case of level rise in the vessel.